Hi, hello everyone. My name is Bingjie, and today I will present my final project, and my topic is detection and disambiguation of personal names and addresses. Yeah. Okay. Detection and disambiguation of personal names and addresses is the task used to recognize personal names and addresses in English text. This task belongs to named entity recognition (NER), and the goal is to find out the names and addresses in a task and correctly categorize them as either personal names (PER) or addresses (LOC). For example, in the sentence, John Smith lives at 123 Main Street, Springfield, IL. The programs need to recognize John Smith as the person's name and 123 Main Street, Springfield, IL as an address. In the sentence, Washington agrees to proposal. Washington could mean the person's name or something else. This task requires the programs to understand the context of sentence because the names of a person and the address may have multiple forms that can be easily confused. For example, Springfield has many places in the US, and while Jordan could be a person's name or a place. To accomplish this task, an artificial intelligence model called BERT can be used. It can recognize people's name and addresses from contextual information. And even if there are spelling mistakes or abbreviation in the text, for example, it can recognize 123 Main Street um, as 123 Main Street and NYC as New York City or York City. There are many uses for this task, such as in customer service system, where the program can automatically extract names and addresses from emails or conversations to improve efficiency, and in search engines, where the programs can better find information related to a person's name or address. And the CoNLNL 2003 dataset is a tool for training and testing computers to recognize information such as names of people, places, organizations, and dates in text. It's a very well-known dataset, mainly used for named entity recognition and ER tasks. And the data is compiled from real news articles containing many sentences, and each word is labeled with its category, such as whether a word is a person's name, a place, an organization, or just a plain old words. For example, in the sentence, John lives in London and works for the BBC, and John is labeled as a person's name, PER, and London as a place's name, LOC, and BBC as an organization's name, and ORG. By learning this annotation information, the model can recognize similar entities from other unlabeled texts. Okay. These tasks use BERT to recognize people's name and addresses in sentence. BERT, B-E-R-T, bidirectional encoder representation from transformers, is a leading pre-trained language model that is widely used in natural language processing tasks, including named entity recognition (NER). Sorry. In this text, BERT is used to recognize entities in text such as names, places, and organizations. It will first divide the sentence into small word fragments called token, and then generate a numeric vector for each word fragment that represents its meaning. BERT understands the meaning of the whole sentence by analyzing the content before and after each word fragment in the sentence, and thus determines the types of each word more accurately. To adapt to the NER task, BERT adds a classification header to the output layer to classify each token and predict its corresponding entity label, such as person's name, PER, or location, LOC. The model ignores special tokens such as CLS and SCP and focuses on the parts of the sentence that actually needs to labeled. During the training process, the model learns to match the predicted labels with the real labels through the cross-entropy loss function to improve the accuracy of classification. Yeah. Um, this project runs on Windows 11 platforms and is coded in Python 3.12.8. I mainly use TensorFlow and Keras to train models and Flask to develop text applications. The following libraries need to be installed prior to training and validation. Yeah, and in the data analysis phase and training phase, you can view the data analysis results, train the models, and save the model by running the code blocks in data analysis IPYNB and train IPYNB insert. It is worth nothing that although our task is detection and disambiguation of personal names and addresses, during the training process, we take the identification of all entities in the CoNLL 2003 dataset as the training goal. In example, we identify the sentence name of people, PER, places, LOC, organization's name, ORG, and miscellaneous categories, MISC. On the one hand, this reduces the unnecessary data processing process, and on the other hand, it has been shown that multi-task training helps to improve the performance of the model on the main task. In the result, presentation phase, the command line goes to the directory of this project, and after running it in the appropriate Python environment by typing Python app.py, the web application can be used by using a browser. Yeah. Total number of train validation and task records are 14,041, 3,250, and 3,453. The distribution of tags is shown below, and it can be seen that this is a multi-classification text with an imbalance of text. Yeah. The distribution of sentence length is shown below, and it can be seen that all sentences are within the range of length that BERT can predict. The variation of the model loss on the training and validation sets during the training process is shown in the figure below. Since the BERT BRT model is pre-trained, only three epochs are required to fit it on the task. The matrix of the model on the task set are shown below. It can be seen that although the performance is low for predicting the two labeling model BMISC and IMISC, however, for the prediction target BPR, IPR, BLOC, and ILOC. For these tests, the F1 scores of the model are 0.97, 0.99, 0.93, and 0.85, respectively, which is an indication of the excellent performance of the model for recognizing the two types of entities, persons' names and addresses, in structured task. Finally, we developed a web application which for a given task recognize the names and addresses of a person in the text. The interface of the app is as follow. For the text, John lives in London and works for the BBC. Our application successfully recognized John as a person's name and London as an address. Our project showcase both innovation and practically in solving the task of recognizing and disambiguating personal names and addresses. One of the key strengths is its accuracy. By leveraging the CoNLL 2003 dataset, the model achieves excellent accuracy and F1 scores. Effectively identifying and resolving ambiguities in names and addresses. This makes it highly reliable tool for such tasks. And another highlight, it is practical application. We've developed a user-friendly web interface that allows for real-time testing and visualization of the model's output, demonstrating its utility in practical domains such as customer service and information retrieval. However, the project is now without its challenges. Training and fine-tuning BRT, while powerful, its resources intensive, requires significant computational power and time. Additionally, the project's focus on the CoNLL 2003 datasets means it may not generalize well to other dataset or languages without further adjustment. For now, its scope is limited to English text processing. Despite these limitations, the project highlights the powers of cutting-edge technologies like BERT and offers clear potential for further adoption and enhancement in real-world applications. And in the process, we learn in depth how to use contextual information to solve the ambiguity problems in text and experience the powerful role of transfer learning in natural language processing. In the future, we can try to extend the model to multi-language scenarios and optimize the real-time and scalability of web applications, as well as exploring its application to more complex real-world scenarios, such as customer management or document analysis. I will describe the web app I have developed. This application is a named entity recognition highlighter, NER entity highlighter, that recognizes categories and highlights names of people and places in text. After typing a sentence in the input box and clicking the Analyze button, the system will automatically analyze the text and identify the names of people with the label PER and the names of places with the label LOC. The legend section at the bottom provides a description of the label to make it easier for the user to understand. If the user does not enter any text, the system displays a red arrow message showing please enter some text. And I'll demonstrate this by typing John Smith list at mainstream Springfield.il and into the input box and click on the Analyze button. And based on the output, we know that John Smith is the person's name and mainstream Springfield.il is an address. And these two is simple and intuitive, and it is suitable for the presentation of natural language processing task and preliminary application of text analysis. And this is my presentation of today. Thank you so much for listening.